My name is Hervé Rogero, and I will be discussing the high-level differences between AWS RDS SQL Server and Azure SQL Database. At a quick introduction of myself, I'm the founder of Enzo, which is a data virtualization for SQL Server. And you can find information online at this address. And of course, I don't tweet very often, but I monitor what's going on. At the bottom here, you have my Twitter handle. Feel free to connect. So today, we will be doing a high-level overview of the two platforms and kind of define the scope of the discussion tonight specifically. We will take a look at a number of differences between AWS database as a platform offering and one provided by Microsoft, specifically in terms of the number of offerings available, connectivity options, some known limitations of the T-SQL language, differences in availability, licensing, backup and security, scalability, and also pricing. I actually spent some time recently on pricing, and I came up with a way to kind of present some of the differences between the two platforms. So what's in scope? Specifically, we will be talking about SQL Server as a service. Most of us have spent a lot of time with SQL Server, either implementing the database platform on virtual hardware, even physical prior to that, and running them in in hosted environments. But when it comes to running SQL Server as a service, we're looking at a PaaS offering, platform as a service implementation of SQL Server. And both Amazon and Microsoft have an offering for SQL Server as a service. And tonight, I want to discuss kind of the high-level differences. We can go really deep and perhaps even in rabbit holes very quickly, depending on how detailed we want to be. But I wanted to keep the discussion a little bit at a higher level to keep the frame of reference a bit easier to discuss. And of course, I will be talking about the pros and the cons of each platform from a selection standpoint. What I'm going to keep out of scope of the discussion tonight is anything that you would be running yourself, either through a form of virtual machine implementation in Azure or EC2 instances or even on-prem implementations. So we're keeping that discussion outside. I'm also going to avoid low-level performance details of the two platforms. Provide some detail, but I don't actually have information to present today in terms of benchmarking. So I just want to make sure we're going to set that expectation. So what are the current offerings available? In AWS, Amazon has created a service called RDS, which is a platform as a service offering that can run multiple database engines, including Oracle, including Postgres and others, and MySQL. But SQL Server, of course, being the topic for this evening, is the Amazon offering. So RDS for SQL Server is an offering from Amazon that offers multiple editions that you can choose from 2012 all the way to 2017. I checked a few days ago, 2019 was not yet available on RDS, but I'm pretty sure at some point it will become available. And on the Amazon platform, you can choose multiple editions. If you want an Express edition, you can. If you want a Web Standard or Enterprise, you can choose that as well. We will talk about some of these implications later, obviously. And the way this works is that every instance that you create in Amazon is basically a dedicated instance. It's yours. It essentially is running on a virtual machine that's dedicated to you as a customer. The equivalent offering, or the competitive offering, I should say, from from Microsoft is a little bit more integrated solution, and it's called the Azure SQL Database offering. It's a service that offers you one version. It's basically 2019, and it always runs on the latest available binaries. It offers the Enterprise Edition. That's the only edition, really. You don't have a choice. That's what you get, which means you have a lot of features available at your disposal. And you can run it either in a shared model or a dedicated instance. Shared being that you're not the only person sharing the virtual machine infrastructure running the service. You're going to be running a SQL Server among other customers. But there is, of course, a really strong separation of duty and isolation, meaning that your database is actually not available to other customers, obviously. But it means that you are sharing certain resources on the machine as it comes, when it comes to memory and chemicals. The dedicated instance doesn't. It gives you, your own environment. And there are three distinct implementations on the offering. You either have, well, actually, it's really, it should say two implementations. You have the Azure SQL Database offering as a service where you have either as a single instance and it runs as either your own instance virtualized or in what's called an elastic pool, or also as a serverless implementation. We will review these three options later. And then you can have your managed instance option, which is your dedicated instance. So it's either in a shared environment or in the dedicated environment. In the shared environment, you have those three options: single, elastic pool, and serverless. So let's talk about connectivity first. AWS has a very standard implementation model, which at a logical level, you have a client and you want to connect to your database. You basically use the DNS name provided by Amazon, and you're going to hit that server directly. So you might expect, well, that's kind of business as usual. If you were to implement SQL Server yourself in your infrastructure, that's the way it would work. The Azure SQL Database works a little bit differently. It works through a gateway mechanism. So the single database offering, which is the first one on top here, goes through a gateway at all times. So you have the DNS name that you get is not actually the DNS name of the server running your instance. It's the DNS name of the gateway, and then you get routed to the correct instance. In the another option is to use a redirection mechanism, where you would first connect through the gateway, and then the gateway, since it knows where the instances are, will redirect you to the correct server. So this redirection of the gateway from the DNS gateway directly to the virtual machine that's hosting your instance is what's offered by the managed instance offering. There's a case to be made as to why this was done, but it really has to do with connection pooling and a little bit of performance improvement when you have a direct connection to your database.
So I have a question. Who manages the gateway?
Microsoft does. To you, it actually looks like the master database. So it really is a routing engine that looks like master to you, and then when you connect and say, I want to connect to my database, ABC, this is actually the database that you're going to be connecting to. So a master really doesn't exist physically in this environment, in this world.
So is this gateway essentially any different than NAT?
Yeah, you can look at it this way. It literally is a router. So when you connect to that gateway behind the scenes, you're basically redirected transparently to the server that's hosting your database. And the primary reason for doing this is that it allows Microsoft to easily shift this database and port it into a different server transparently, or you're just connecting to the same endpoint every time from a client standpoint.
Okay.
Okay. And we will see this a little bit later in action when I'll do the demo quickly through SQL Server Management Studio.
Sure.
So there are differences in terms of what you can do as a database developer. You're used to doing a lot of things. Your standard commands on select and sort of date, of course. But then when you start going into some more advanced capabilities, you might actually be surprised that certain things don't work as expected or don't work at all. And so depending on the offering, and depending on Amazon versus Microsoft, and specifically on the edition, but also on the version of the service you're using in Azure, you may or may not have certain capabilities. So this is not meant to be a complete list of differences. This is my best attempt at collecting information, both from documentation, but also personal experience. But this is, I don't guarantee this to be 100% accurate and nor complete. But for example, you're going to have certain things that are available in RDS just because of the way the service is implemented in RDS. It's more of a standalone SQL Server that's being run for you, as opposed to the Azure offering, which is a tailored service where the binaries of the engine have been tailored to provide highly scalable solution. So for example, database mail is not available unless you actually go to the managed instance in Azure. Log shipping is just not available anywhere. Open Rosette has been added recently on the Microsoft platform. It's not available in RDS, and so on and so forth.
So, even when you are in AWS, even when you are using an enterprise edition, this Open Rosette won't be available.
Correct.
HA won't be available.
That's right.
Wow.
Yeah.
That's a severe limitation. So even though you have those virtual machines sitting out there and you configure them with enterprise edition, AWS RDS would not support that.
Well, so again, this is not an EC2 implementation. If you install SQL Server yourself on EC2, sure, you can do whatever SQL Server allows you to do. Where this is specifically the RDS instance where SQL Server is run for you and operated on your behalf as a platform as a service.
Gotcha. Okay.
And so there are some limitations as a result. Yes.
Gotcha. No, makes sense now. Thank you.
Right? Yeah. Yeah. You're welcome. Sure. So of interest here is, transparent data encryption, right? So of course, this is a security feature that encrypts your data at rest. In AWS RDS, sure, you could have that enabled if you choose the Enterprise Edition. In Azure, since by default, and the only choice you have is to run the Enterprise Edition, you can use TDE at any time. At one point, actually, I thought transparent data encryption was required in Azure, but I actually noticed recently that you could actually turn it off. So it is an option in Azure now. An interesting option, for example, you can see in some cases like change data capture is something that you get with AWS RDS, but not in a single database instance in Azure. You need to go to the managed instance to get that option. And it's actually really hard to pull this information together. It's really interesting. The documentation is really hard to actually nail down. Right? So just keep that in mind. Some of the options are provided by the service, but some of the options you might have some restrictions. Let's say, and in other cases, it depends on the tier that you select.
Gotcha.
For example, bulk insert is the command itself is available in Azure, not in RDS. It's available in Azure, but only if you point to a blob, an Azure blob, more specifically. All right. So in terms of availability, the RDS, AWS RDS service offers has two options. Option one, if you only have one instance of your database, then you have no SLA because there is no high availability. So if you don't choose an HA option in RDS, you have no SLA, period. To get an SLA of 3 nines and a half, you must enable the high availability option, which is the multi-AZ option in AWS RDS, which actually now uses always on, if I recall, or log shipping, depending on the edition of SQL Server. But it's behind the scenes, so you don't touch that. It's a checkbox for you. But what that means is that the secondary server is being provisioned, and your cost, whatever it is now doubled. It's a direct math. So of course, this can be pretty expensive if you're depending on the number of databases you have. But keep in mind that the secondary database is not accessible. In the Azure SQL Database offering, there is a little bit of a difference depending on your selection, if you pick a single database offering or managed instance offering. The single database offering has a secondary database always behind the scenes that's always maintained for you. And so you can get up to 4.5 nines availability. And if you use the managed instance, you can have multiple replicas, including one read replica if you choose so. So you have here kind of a and it's using always on availability groups. So you have very different capabilities here when it comes to your availability of your database. There is no.
I have a quick question.
Yeah, go ahead.
So for the Azure SQL Database, you're saying that there is a secondary node, but it's not accessible. Is that correct?
Correct. Just like for option 2 in RDS, it's only there to provide the availability that the service guarantees.
Just so in case that particular database goes down, they have something else to go to.
Yes.
Okay.
And Microsoft actually uses that a little bit differently than RDS. While that's what you just said is true for both services, the other thing as well is that Microsoft from time to time will use that secondary database and migrate the service over to that secondary database and use another one as the secondary. So Microsoft will use this technology to actually shift workloads in basically server racks to be able to move your database around depending on its performance needs. So it's more of a dynamic capability.
Mm-hmm. So if you had an application, for example, that was writing to the primary node and you wanted the application to do a report or something from one of the secondary nodes, they would have to use the managed instance offering.
Yes.
To accomplish that.
Yes, and enable secondary reads. That's correct.
Okay, thank you.
Sure. All right, so this is in a nutshell kind of the high availability options. Licensing also gets interesting. As of a few months ago, almost a year now, I guess, yeah, just about a year, Microsoft changed its licensing rules, and bringing your own license is no longer possible on AWS RDS. So you have to use the license included model, which is not necessarily a bad thing for most customers, but there's a gotcha there. So ultimately, when you provision a database instance in RDS, Amazon RDS, you're going to pay for really Amazon's host cost plus the licensing cost that Amazon needs to collect, right? Because it's obviously it's paying for licenses behind the scenes. So you have to you it looks like just one price, but essentially you're paying for two things. And it's really clear when you provision a SQL Express database in RDS, because license is free. So what you get there is the bare bones cost of running an RDS instance in Amazon. The thing there is that when you turn on high availability, that cost doubles, because now you're paying for another server, another host, and then you're paying for another license if you're selecting a licensed edition of SQL Server. And in the Azure space, you have the single instance database has two pricing models today, the vCore model and the DTU model. And the managed instance, I think it's vCore. If I'm Darius, correct me if I'm wrong, but I think it's just vCore. The DTU model is what used to that was the only model available a few years ago, and it basically is a fuzzy definition of price performance. So you're getting a mixed bag of an average performance of a database engine with both CPU and memory to give you a rough throughput. And this is extremely fuzzy, but it works for for a lot of environments. In this particular model, you cannot bring your license. However, in the vCore model, if you price an instance by vCore, you're going to say I want 2 vCores or 4 vCores or whatever, and now you can bring your license. You can bring your license if you have an on-prem license. You can have discounts in the cloud. And this is where we will talk about this again on my last slide when we talk about pricing. This is where you can get some interesting discounts. So licensing can be a bit tricky, but when you provision an Azure SQL database, you're going to have to make that choice at that point. Do I want a single instance? And if yes, you're going to have a calculator that you can easily slide bars and say, okay, this is how much DTU do I need, or how many vCores do I want? If you want to try to compare costs with Amazon, you would need to pick a vCore because Amazon sells a host, and so you in Amazon the only option is a vCore option. Let's talk about backup a little bit. So I did not refresh this particular slide in a few months. I believe it's still accurate. And your backup and restore options are a little bit different depending on the offering and depending on the service level. So essentially, the backup command and the restore commands are both available in RDS SQL Server, just like you would expect. In the Azure space, it's a little bit different. In a managed instance, you can do a backup, but you can only restore in a managed instance. You can't restore it elsewhere. In Azure SQL Database, you actually don't have the option to do the backup or the restore operation. But what you have is automated backups, so with various retention periods. The retention periods depend on your service level. because you can choose a basic edition or business edition or things along those lines. That gives you different retention periods with also recovery point objectives. So all offerings give you RPO of 5 minutes. And the Azure SQL Database, a single instance, can give you also a long-term retention plan of up to 10 years. I haven't tried it, but it's there. So something that's interesting, and this is where you start to enter the differences in the implementation of the architecture of both offerings of Microsoft and Amazon. Amazon basically gives you a SQL Server, and you can have multiple databases on it. And because of the gateway concept in Azure that we talked about at the beginning, you could actually have multiple databases under your gateway, but they are not running on the same machine. They're all spread out on different virtual machines. So you have really a logical server concept, a logical instance. So when you do a backup, and you try to recover from the automated backup, what you can recover is the database. Let's say if you've got 3 databases under the Azure, under an Azure instance, these 3 databases are potentially running on different VMs, on different environments. So what you can recover is the database, per database. In AWS, because you're getting basically SQL Server run for you, what you do is you can back up and recover the entire instance. Security is also really interesting. So the RDS service does not really, it offers a firewall, but it offers a firewall through its security groups. So RDS has the concept of security groups, which kind of separate. It's a networking thing, which allows you to separate that from the actual database service, and they are able to provide firewalling so that you can only allow connections from specific ranges of IPs. You can also optionally provide an SSL encryption endpoint to your database, but it's not required. You can also have encryption at rest using transparent data encryption, but this is only available for the enterprise edition of SQL Server. So if you don't use the enterprise edition of SQL Server, you won't be able to use that feature. And it offers both SQL Server and Active Directory authentication. The trick there, however, is that this Active Directory is actually going through another service provided by Amazon that you would need to stand up in order to implement Active Directory authentication. And it does not tie back to Azure Active Directory. So whatever you do from an AD authentication in RDS is going to be leveraging an intermediate Active Directory environment that can tie back to your own on-prem Active Directory through one-way trust. You also have the auditing capabilities of both SQL Server, but also RDS provides auditing at the service level as well. In Azure, there is a firewall, except for managed instances, but the firewall works a little bit differently than in AWS. And there's a little diagram here at the top, but ultimately it's a dual lock mechanism. Either you have access at the database level directly, and you can connect to the database. If the database itself does not allow that particular IP address to connect, then the firewall will check at the gateway level and figure out if you have an overriding rule that allows you to connect to the database. So it's kind of a double mechanism. So you can either manage firewall access at the database level or at the virtual instance or the gateway level. SSL is always required. Encryption at rest is optional. It's a simple option, to enable. You can also have SQL login authentication or Azure Active Directory authentication. You have full-blown auditing, and then you have additional capabilities that are only available in Azure, which is advanced threat protection and data masking. So these are, built into the Azure service, and Microsoft, of course, because Microsoft owns its licensing rights and it owns the code of Microsoft SQL Server, it is able to add some specific capabilities that are not available in AWS RDS as a result. So I would say, in general, the security features of the Azure SQL Database are definitely superior. So here's a slide that gives you a high-level summary of what's available for the single database offering or the managed offering and versus AWS RDS. And you can see that SSL encryption, is required in Azure, but optional in AWS. You have the ability to define user-defined certificates for your encryption for TDE. VPN connectivity is available everywhere. Public internet access to your database is possible, except for managed instances, which require you to go through a networking environment, a private network. The firewall rule are available for the single database and elastic pools offering in Azure and AWS RDS. What's interesting is that if you define your firewall rules at the database level, then they become portable, meaning that if you restore your Azure database in the future somewhere else, then these firewalls tag along, right? They're backed up. They're inside the database. Data masking and advanced threat protections are available only in Azure, and auditing is available everywhere. So this kind of gives you kind of the overall summary. Any questions before I move on? No. Scalability is also an interesting topic and really complicated when you go into the Azure space. In AWS, your scalability options are basically it's a vCore model. So you can have one vCore, two vCores, four vCores, and your scalability basically is directly proportional to the number of vCores available. You can go, at the time I wrote this slide, it was up to 48 cores and 384 gigabytes of RAM. I didn't check this week if this was still accurate, but it should be roughly accurate. And in Azure, what's interesting is that you can also scale up quite a bit, but there is a major difference in the way the offerings are provided. The Azure offering has an almost infinite, not quite, but almost infinite number of fine-tuning options in exactly what you need from a scalability standpoint. You can say specifically with the DTUs as well, you can have fine-grained options, hundreds of permutations of scalability options in Azure, just because of the fact that it's extremely fine-grained. And in AWS RDS, because what you're getting is an instance, is a dedicated instance, you don't have the same level of granularity. You have, it's like a knob with 10 stops and nothing in between. So you have to choose, the instance with the memory that comes with it. And as a result, when you start looking at the details of how many options and how many sizes you have per edition, there's of course a large number, but it's definitely rather limited compared to the Azure offering. So the reason I mentioned that is I know firsthand on the implications this can have when you want to run an environment, even if it's not an enterprise edition of SQL Server. If you're happy with the standard edition, if you need high availability, your cost really goes up very quickly. You can only go down so far, and that's one of the major drawbacks of the AWS service from a scalability standpoint. It's not necessarily how far up you can go, but how far down you can. And it's very, very hard to go and have a kind of a small amount without going all the way down to the Express Edition world. In Azure, you have workload consolidation options as well with the Elastic Pool service, which really is part of the single instance offering. But you now also have the serverless compute, where this is really for, consider this mostly for dev test scenarios where your billing is no longer by minute, it's by the second, and it may take a few seconds to warm up the database instance, but you pay for what you use, and if you don't use the service for a few minutes or a few hours, it'll shut down automatically, and you'll stop paying. So this is the other end of the extreme in terms of scalability, on how low and how granular you can be in this particular offering. The last time I checked, which was really about a couple of weeks ago, last time I checked, the CPU clock, the CPU speed and the memory footprint was pretty similar in both platforms, RDS and Azure. Which brings me to pricing. And pricing is very, very difficult to calculate, and you have to make some assumptions. The challenge is that Microsoft and Amazon are really smart about how they price, really, really smart. And they're going to do everything they can to make sure that you cannot compare the two services. And literally, you have to make some assumptions, and you have to really read the fine prints to be able to start comparing apples with apples. And even then, it's hard. So what I did is actually I created a scenario. It's something that I thought was relevant. And I decided to simulate what a development environment that has a production server would look like. And I think it's when you look at it this way, and when you look at it at your workload as a group, is the best way that I thought I could compare the pricing options of both environments in a way that was as similar as possible. So for example, I picked a production environment that has 8 vCores standard edition. I didn't go enterprise edition because in this particular case, it was not necessary. But had I picked Enterprise Edition, the difference would have been significantly greater. But I decided that my production environment had to be highly available. So in the RDS environment, then I need to pick the multi-AZ option. And for pricing comparison, I'm making a 1-year commitment for pricing, which when you commit, to a specific duration on your service, then you get a non-negligible discount. So I was able to do that on both in Amazon and in Azure. However, for my dev test environment, I wanted to have a dev test environment with 2 vCores only, standard edition, no high availability, and on-demand pricing. Because the assumption here is that maybe I'm going to be developing for 3 to 6 months, but then I can shut off my environment. If I don't shut it off, then of course I'm going to pay a little bit more. So this is kind of a scenario that I thought was relatively relevant. And in the AWS RDS SQL Server, then an 8 vCore, I had to pick the edition and the class of the server that I was going to use, and I picked an R5, which gives me 32 gigabytes of RAM with 8 vCores, which is the R5 2X large. A standard edition multi-AZ 1-year commitment, and when I price that, it's roughly $50,000 for my production environment. The equivalent offering in Azure would be an 8 in a vCore pricing model, not the DTU pricing model. In an 8 vCore environment would be what I selected had 4 gigabytes of RAM, enterprise edition because you don't have standard edition, business critical, generation 5 with 1-year commitment, and that came up to about $40,000. So you can see that it's not cheap, in neither place, and depending on how, exactly what you need, there are cases where, especially if you need the enterprise edition in RDS, your price difference is going to be, significantly greater, giving Azure an advantage on pricing at that point. So that's why I stayed standard edition. On the dev test, what I'm selecting here is an M5 in RDS, which is a kind of a little bit lower end server class with 2 VPUs that gives me 8 gigs of RAM, standard edition single AZ because I don't need high availability. And since I have a dev machine and a test machine, it's $8,000, a little bit over $8,000 times 2. And in Azure, the equivalent offering with a 2 vCore, 10 gigs of RAM, general purpose edition, gives me, something around the lines of a little bit over $4,000 times 2, right? So when you do the math, you end up with something in Azure that's definitely cheaper. It's and I invite you to check yourself because it's very difficult to have it's very difficult to compare again what you're getting in both environments. You have to spend a lot of time reading in the fine prints. Putting this together took me hours actually. So this was a lot of reading and a lot of comparing, making sure that I picked something that was as close as possible in both environments. Keep in mind as well that because Microsoft changed its licensing agreement last year, you can also, if you have either an MSDN subscription or if you have an on-premise license available, your licensing costs in Azure could actually drop further, with something along the lines of 55% reduction in cost. So this is not included here. I'm not assuming that I have MSDN. I'm not assuming that I have on-prem licenses that I can use.
That's a lot of work, Hervé.
Yeah, this took a while, and I have a lot of background calculations and a lot of details. If you have, I'm happy to answer any specific questions you may have offline because it'll take time for me to answer any of your questions around pricing.
Sure.
But I've spent actually more than days, actually more than hours, in calculating return on investment over a 5-year period to show the difference in pricing. But I wanted to give you kind of this high level information because I thought it was really relevant.
Sure. No, thank you so much.
Mm. So I'm going to switch to a quick demo. We definitely have more time, but I just want to show you a couple of things. But at a high level, the way I see the AWS RDS implementation is that it's easier to adopt when this is your first cloud migration. If you've never done it to the cloud, if you have legacy applications, because the service is a little bit simpler. It's simpler because it's closer to what you know. It really is a VM with an instance running on it. And so your adoption curve is going to be perhaps a little bit simpler. Microsoft recently, I shouldn't say recently, but a couple of years ago, introduced the Managed Instance Edition, which gives you a similar capability with a lot of options, very similar to what you would have today. But still, in the end, because of the way the service is built in Amazon, because of the limitations of Amazon, for legacy apps, I think it's a little bit easier. It's not necessarily the right choice, however. I think in Azure you get so much more, and so spending a little bit of time understanding Azure, spending a little bit more time on your architecture, implementing basic retry mechanisms and things along those lines will get you much higher availability, stronger security options, so many more scalability options. You're always going to be on the latest binaries, meaning that your security fixes are going to come in faster, much faster than in Amazon, and significantly more pricing flexibility. Back to AWS, as I was saying, forklifting is easier for one reason, is that you don't have to update your edition as long as you have something on 2012 or later. Right. So what I'm going to do here is spend a couple of minutes on. So this is the RDS console, and I don't know if you guys all joined at the very beginning of this presentation, but I lost my password on this particular database, so I will not be able to log in from SSMS, but I guarantee you it works. I just wanted to show you a little bit how the AWS console kind of looks like and how it works. So I've got an RDS instance over here, and as you can see, I'm running the Express edition. It's a very small size, of course, and nobody's connected. So you have just high-level information over here. And then when you click on your database, now you have more information about where it's at. So for example, this is your endpoint. This is your DNS name, which literally will point directly to where the database is running. I can see here some information about the configuration of my database. Of course, encryption is not enabled. It's an SSD storage type, 20 gigs of storage. The master username is here. I mean, maybe you can try to hack it. Now you have all this information, and if you find the password, please do let me know. Okay. License included. That's now, of course, the only option. And what you on the security side, as I was mentioning in the presentation, the security groups is how Amazon implements its firewall mechanism. So when you go into the VPC configuration settings, you can see the IP address, the port range, and the range of IPs that's allowed to connect to that particular database. You have, basic CloudWatch monitoring provided by Amazon with, your storage, your database count, connection count, CP utilization, and so on and so forth. You also have advanced monitoring capabilities. That's an extra cost, but this is also available for SQL Server. So what I'm going to do now is, I don't know why it's not here. All right. Now this is the Azure portal. So on the left here, what you see is my list of my database servers, my database instances, and my actual databases. And this is where this is a little bit different. Where, for example, if I select this, the first one here, because of the little icon, I know, and it doesn't have anything on no parenthesis, I know this is an actual instance name. But as I mentioned earlier, you have a server name here, but don't be fooled. This is not really a server. This is a gateway, right? So at the server level, what you have at the bottom here, you can see I've got multiple databases created, and they are attached to that server, but it's only a logical link. These databases are not necessarily running on the same hardware, on the same VM, actually. And on the right, what you see is kind of the pricing tier. So these are all basic, and this is a standard edition database with not standard edition of SQL Server, but it's standard pricing tier. It's still an enterprise edition with 10 DTUs. Right? So I've got a DTU model for that particular database. And what I'm seeing here on top is the firewall settings. So if I click on this, then I can go to my firewall section, which is down at the bottom, and you can see, the firewall definitions. I wanted to show something else over here. Over here, you can manage your backups. This is how you define the Active Directory administrator, and you have, a variety of options. So the firewalls that are here. These firewall settings that I just showed you, these are at the instance level, at the gateway level. So what I'm going to do now is actually go to one of the databases. I can either click here or on the left. I'm going to go to the dbcust database. So when I click on it, this is now my dbcust database, and it's logically attached to my server. And at this point, I've got high-level utilization. Compute, it's a compute utilization, DTU computation. So I can see my storage allocation and how much I'm using. And I have my connection strings. So when I click on this, I can see my connection strings over here. Here's where you set TDE if you want to turn it on. Data masking if you want to do a dynamic data masking of columns for sensitive data. Right, so all your options are right here. So you see it's a very different experience from a user interface. That's kind of at a high level of what I wanted to show you guys. Now, when it comes to the database, so what I'm going to do here is register my my Azure gateway, right? So I mentioned it's kind of a logical master database. So I'm going to log in, make sure and no, it's not password. And what's happening here is that, as you can see, if you're familiar with SQL Server Management Studio, what's actually coming up is limited on the left, and it knows it's talking to Azure SQL Database. So when I expand my databases, because I'm actually technically connected to master, you can access the list of databases that are available and attach to that logical instance. From here, I can then connect to the database directly. And what's interesting is that you're now connecting through the gateway. So when I run this command, you're talking to this gateway, but it's actually routing the request to the proper instance in the background that actually is hosting my database. All right, so at this point, the experience is roughly similar, except the user interface, it doesn't give you all the options that you might be expecting compared to an on-premise environment. But that's ultimately, you have your SPID. You can see I'm not the only one on that instance. I already have a SPID of 72. It's pretty fast. It's all TDS is a pretty quick protocol. So I'm able to communicate easily. And the only reason I was able to connect is because I set up my firewall properly. If you don't have your firewall set up properly, you won't be able to log in. And that's all I had to share for tonight. Giving you a high-level overview of both platforms, a quick tour so you can see the user and the end user experience, and kind of the various options of the services available.
Thank you, Hervé.
Yeah, you're very welcome. I'm open for questions. Oh, I did a really good job. That or everybody's on mute.
Hervé, it's Darius. Great job. Maybe I missed it, but why does Azure SQL Database provide a higher availability? Is it just SLA, or is there something technical that I missed?
Yeah. So we talked about availability here. And the service SLA in Azure is 4 nines and a half out of the box, whereas in AWS, with a single AZ implementation, you have no SLA, and you have 3.5 uptime when you enable multi-AZ. Okay, so that's the first reason. The second reason is that you have additional options with managed instances where you can have multiple replicas, including a secondary read replica if you want to, which is not available in Amazon.
Excellent. So it looks like I was distracted during this particular slide. Thank you.
Sure, you're welcome. Yeah.
Hervé, did you get to play with the serverless SQL model that turns itself off and brings itself back up? Have you worked with any projects that work with that? Is that a big obstacle for the cheap cost?
You know what? I actually have not. I mean, it was in preview for a while, and recently I saw the option light up, but I actually have not played with it. But essentially the premise behind this database, which I could certainly use that, is that if you don't use your database for days or weeks at a time, or let's say you're not going to use your database environment over the weekend or something along those lines, serverless totally makes sense. It shuts down automatically and it restarts on demand as soon as you try to connect.
So yeah, let's say it takes like 20 or 30 seconds to come up, right? You just give the user a special message.
That's correct.
And, yeah.
Could take some time, yeah. Which is why it's better suited for, dev test environments.
Hi, Hervé. Great job. Did you do the pricing based on a particular region, like East Coast or West Coast?
Yeah, I should have written that one down. Good point. It was definitely US. and I believe I used US East for Amazon, and either East or South Central for Azure.
All right, thank you.
Yeah. All right, great. Well, guys, thank you very much for joining tonight, and feel free to contact me if you have any questions.
Thanks a lot, Herb.
Thank you, Herbie.
Thanks,
All
Larry.
right.
Thank you.
Thank you, Hervé.
All right.
Thank you,
You're
everyone, for attending.
Thank you.
All right. Have a good evening. Bye-bye, guys.